Good evening. My name is Martin Muley, tutoring mathematics. Today we are going to discuss about differential equation. Differential equations. There are so many types of differential equations, but we are going to discuss the differential equation of the first order. So we can have an example of a differential equation of the first order given as dy all over dx plus p y is equals to q, where p is equals to 5 and q is equals to the exponent raised to power 2x. This means p and q are the functions p and q are the functions of x. Now we can write the differential equation above. The differential equation is dy all over dx plus 5y is equals to the exponent raised to power 2x. Now we need to find the integration factor, and the integration factor will enable us to solve the above differential equation. Now the integration factor is e raised to power the integral of 5 dx, which is equals to e raised to 5x is the integration factor if. Now with the help of integration factor we can now solving the differential equation dy all over dx plus 5y is equals to e raised to power 2x, but the integration factor if is equals to e raised to power 5x. We multiply both sides by e raised to power 5x. We have e 5x dot dy all over dx plus 5y e raised to power 5x is equals to e 2x e 5x. Now from this point we can evaluate and get d all over dx into brackets y e 5x plus plus 5y e raised to power 5x is equals to e raised to power 7x, using the law of indices, whereby the exponent multiplying, we don't multiply actually the powers. We are supposed, because the exponent, this is the same term, we are supposed to add. Because we are multiplying the exponents, we are supposed to add the powers, and that is why we are getting e or exponent raised to power 7x. From there, now differentiating this one, we are going to get this one. So it follows what we call a chain rule. Differentiating this one using chain rule, we are going to get the first one, because we have y, we are going to get e raised to power 5x dy all over dx, and the second one plus, we are using the chain rule, we are differentiating this one, and the second one becomes here we are going to differentiate e raised to power 5x, whereby we are going to get 5 y then raised to power 5x. Now you can see this one and this one is becoming the same thing, so meaning e raised to power 5x is becoming our integration factor. I was only trying to elaborate when you differentiate this what you are going to get. Now from this equation, let's say this was our equation number 1, this was our equation number 2, this is our equation number 2. Now from our equation number 2, we can continue and say d all over dx, d all over dx, then ye 5x into brackets, this one ends, and we are going to have, we shall have this one is equals to e raised to power 7x raised to power 7x. Now from this point, this is our equation number 3. From equation number 3, when we continue evaluating, we are integrating both sides. We are integrating both sides, and now integrating with respect to dx. When we integrate this one, we are going to remain with y e raised to power 5x should be equals to, when we integrate the exponent raised to power 7x, we are going to get 1 all over 7, then multiplied by e raised to power 7x, then plus c, the constant of integration. Now dividing both sides by the exponent e raised to power 5x, e raised to power 5x, then e raised to power 5x, we are going to have y is equals to 1 over 7. Then because this is the division, we are going to subtract the powers. These are exponents, so the terms are the same. The exponents are just the exponents, the same terms. So we are going to subtract the powers. So we shall have e 7x minus 5x is 2x. So power 2x, then plus c. Here, because it is the division, this one becomes a negative power. So it should be e raised to power negative 5x raised to power negative 5x. So that is our solution to the above differential equation. And the original differential equation was this one. The original differential equation was that one. So thank you for the time and thank you for listening. Thank you so much.